Life. I was planning to build a one-story, 100 square meter house and in a warm place by the sea. At first I lived in my parents' house, saved money and gradually moved toward my dream. But it so happened that the house I lived in burned down, and with it, all my dreams burned down too. The plot of land by the sea which I bought with such difficulty had to be sold just so I could have something to live on, and I had to forget about the 100 square meter house as well. That could have been the end of my story, but life taught me not to give up, and I came up with a way to make building a house cheaper and get about the same area with the same 3 separate rooms. I based my design on the Z7 project and simply moved the 2 rooms on the right to the attic, making the space under the roof livable. The first floor of the house was about 50 square meters with over 30 more under the roof. At that time I didn't have a project, so for the first time I made a 3D house model using YouTube tutorials. It's easier than it looks, and I found the house looks pretty nice. The cost estimate showed a significant saving thanks to the decisions I made. You can build this type of house in stages, avoiding large upfront costs, making it ideal for young families planning to have children. I moved back to the Leningrad region, rented an apartment, and after selling my plot by the sea, I had 1 million rubles left, which I wanted to use to start construction. I didn't have any more land for construction. After looking into it, I wasn't afraid to buy a cheap plot in a gardener's non-commercial partnership, and for 250,000 rubles I bought 10 areas of land with an old house on it, which could be conveniently used as a temporary shelter. Although the land was in a gardener's non-commercial partnership, it was inside city limits, with a kindergarten, school, store, hospital, pharmacy, and all necessary infrastructure nearby, making life convenient. Before starting construction in March 2020, when the whole world suddenly went crazy, the universe decided to really test me, and just as I was recovering from the fire, I first got seriously ill, and then I was also in a car accident. These were the conditions I started construction in. If you think something is going wrong in your life, remember me. The main thing is, I survived. And as long as you're alive, anything can be solved. First, I began earthworks on the site, manually removing 5 apple trees in the way, but fortunately some remained. I marked out the building area and using a shovel started digging into the ground, removing the fertile soil layer, which luckily for me was only about 30 centimeters thick. I thought removing just 1 spade's depth of soil would be easy, but I was naive. Next, I dug shallow trenches around the perimeter of the building area with a slope of 5 minutes per meter, installed inspection wells at the corners, lined the trenches with puncture-resistant geotextile, and laid perforated pipes wrapped in geotextile. I filled them with granite gravel, making sure they maintained the required slope. In my case, such drainage around the house was necessary because the groundwater level on the site is very high, and the drainage will keep the sand cushion always dry and help prevent uneven settling of the house. Before pouring the sand, I rolled geotextile over the entire pit so that the coarse sand wouldn't mix with the fine silty soil, which is what the ground on the site mostly consists of. I also manually brought in half of the required sand into the pit, leveled it all out and soaked it with water to initially compact the sand. And then I tamped the first 15 8-inches layer using a vibrating plate compactor which I rented. After compacting the first layer, I brought the remaining sand into the pit to end up with a 30 centimeter thick sand cushion, and then I went over everything with the vibrating plate compactor a second time. I went over each direction twice, both along and across the cushion. What took me 2 months to do by hand, an excavator could have done in 2 days, and I wouldn't do all this by hand a second time. Since the soil is marshy, a large excavator could have ruined everything, which I realized when a big excavator came to dig the pond. So, if I had to do this work again, I'd use a mini excavator and always follow the rule to mechanize anything possible on the construction site. You'll still need to handle the sewage system manually. I used the blueprint to mark and assemble all the required pipes into one system. I marked the cutting spots on paper, then used an angle grinder to easily cut and sharpen the pipes for connection. I tried to make sure there were no 90-degree turns anywhere, only a maximum of 45 degrees. At the sewer outlets, I used not one 90-degree elbow, but 2 45-degree elbows. Don't forget to use lubricant when connecting the elements. Special lubricants work, but even soap or dishwashing liquid is fine, or I sometimes just spit on the pipes, old school. When all the pipes were assembled together, I marked the outlines on the sand cushion and dug a trench with a slope of 2 cm per 1 meter. I laid the pipes in the trench, and while checking the slope of the pipe, carefully buried everything. I checked all the slopes using a laser level, and I highly recommend not skimping on buying one. It's very helpful during the construction process. I poured water on the buried trench to compact the sand and walked over it. To start the next stage, I stretched several cords over the surface of the sand cushion and used a homemade mop to level the surface, aiming for a maximum deviation of plus or minus 10 millinanos. The soil on my plot is fine, dusty sand extremely saturated with water, commonly called pilvan by locals. Jump on it. As further calculations showed, even a strip foundation could have been used for my house on this type of soil, but I decided to play it safe and use a more serious foundation. There was no point in making a full monolithic slab with double layer reinforcement in my case. That would have been a huge waste and just throwing money away. But a foundation like the insulated Swedish slab or insulated Swedish slab was something of a golden mean. It costs more than a strip foundation and insulated ground floors, but offers better load bearing, improved soil load distribution, and greater construction convenience. And the increased cost mainly comes from the larger amount of insulation under the floor, which will actually pay off over time because it will let you spend less money on heating the house. As this insulation, I used extruded polystyrene foam. Under the foundation ribs, it was 50 millimeters thick, and the insulation thickness under the floor was 250 millimeters. If I did it again, I'd place the Penaplex directly on the sand cushion without film and seal the sheet joints from above. At that time, extruded polystyrene cost about the same as regular polystyrene, but now it's noticeably more expensive, so using regular polystyrene for the top 200 millimeters of floor insulation is an option. This would save money, but I'd still use extruded polystyrene the second time if possible. I also immediately laid insulation sheets to create an insulated blind area 1 meter 20 centimeters wide around the perimeter of the house in order to practically eliminate frost heaving of the soil. And this type of foundation also allows us to immediately insulate the plinth, which I made 100 millimeters thick. To make sure the whole structure survived during the concrete pouring, I made shields out of boards. I placed the shields along the plinth and made supporting braces which can be positioned 1 meter apart from each other. Even at the stage of the sand cushion and foundation insulation, 2 embedded pipes were provided, one of which was intended for bringing water into the house. In our gardening cooperative, there was an opportunity to connect to the city water supply, which I did. It cost 72,000. For reinforcing the foundation ribs, I used 6 rods of 12 meter rebar and transverse clamps made from 8 meter rebar, which I bent using a pipe and a simple homemade device made from a wooden pallet. I also tied the reinforcement cage myself using a regular hook and 1 millimeter thick binding wire. Insert the hook into the loop and twist the ends downward. Clamp it down and twist it. I made the rebar overlap at least 40 diameters, which in my case is no less than 480 millimeters. I didn't do the connection quite right. The joints of the rods should not have been in the same place, but staggered. I also reinforced all the corners and started tying the mesh under the floor. For the mesh, I used rebar with a diameter of 10 and laid the mesh rods onto the foundation ribs to create a single structure. The main cell size turned out to be 20 by 20 centimeters. I tied everything together with wire, skipping every other intersection in a checkerboard pattern. I set the rib frame and mesh on plastic spacers to make a 40 millimeter concrete protective layer. In some spots, I used cut cubes of insulation, but spacers are better. They just weren't available at the store. The foundation ribs turned out to be 30 by 30 centimeters and the floor thickness is 10 centimeters. In a typical insulated Swedish slab, underfloor heating pipes are placed on the reinforcement frame. However, I lacked construction knowledge at the time and had to quickly finish the house shell due to circumstances. And underfloor heating seemed like just a dream at that time. The volume for pouring concrete was about 10 cubic meters. I used B25 concrete. And to save money, it's best if everything fits into one mixer, so you don't have to pay twice for delivery. I did the math, and under current conditions, pouring more than 1 cubic meter by hand doesn't make sense anymore. It's more practical to order a mixer. The main problem on my plot is the soil, and when I ordered bulk materials, I found out that a heavy truck can't get onto my plot. The truck just gets stuck. Accordingly, a mixer wouldn't be able to get to the pouring site, so a concrete pump came to the rescue. It's a really cool thing that makes pouring concrete anywhere on the plot much easier right from the road without needing to drive in. My friends agreed to help me with the concrete pouring, and with the concrete pump, the back-breaking work turned into a pleasure. The house foundation was poured without much effort in just 35 minutes. When pouring the concrete, I rented a vibrator. It may seem minor, but it's crucial. With it, the concrete turns out much better. I couldn't find a trowel for rent, so I smoothed the concrete using a homemade mop made from a piece of an old cabinet. The foundation formwork was set level, so I didn't even need to stretch a string. That's how I made an almost perfect surface. After finishing the foundation, we used leftover concrete to pour the driveway, making it easier to unload trucks later. The foundation itself cost $199,000 at that time, but with drainage and a sand cushion, it came out to about $250,000. At the time of pouring, the temperature was almost 30 degrees, so for 2 weeks I took care of the concrete. I watered it and covered it with plastic film. Concrete reaches 100% strength in 28 days. But there's no need to wait that long, so I started laying the walls after 2 weeks. I could have started even sooner. I bought 300 mm thick aerated concrete blocks for the walls. Thermal engineering shows that's sufficient for linoplast and doesn't require extra insulation. The block's strength class is B2, which is enough for constructing buildings up to 3 stories high. First, I rolled out torch-applied waterproofing on the mortar. It could have been torch-applied, but I didn't have a torch. Next, you need to lay the corner blocks. I started from the highest point and using a laser level and stretched strings laid 4 corner blocks on regular cement mortar. The next day, the mortar set and I could lay the entire first row. This had to be done as evenly as possible because the better the first row is laid, the easier and faster the rest of the masonry will go. I laid the first row on cement sand mortar, filling the vertical joint. Next time I'd use foam for the vertical joint instead. The first row of masonry needed to be reinforced. For this, I made 2 small grooves along the perimeter of the entire row. In the corners, I finished the grooves using a sharp cut-off pipe. I filled the grooves with aerated concrete adhesive and placed the rebar in them. For reinforcing aerated concrete masonry, it's better to use rebar with a diameter of 8 mm. Once it dried, I used a float and sandpaper to level the first row's surface. I couldn't make the first row perfectly even, so I thought I could fix it a bit with the second row. I laid the second row using aerated concrete block adhesive, which makes the joint just a few millimeters thick and allows for some adjustment to level the masonry. For the second row, I used foam for the vertical joints. To be continued. I bought aerated concrete blocks with hand grips, which makes the work much more convenient, but it leaves these cavities, which I decided to fill with foam. I later tried tongue and groove aerated concrete blocks, but found them mostly useless. They hinder more than help. The second time I also chose smooth D300 aerated concrete blocks with hand grips, and there's really no point in filling the cavities from the grips with foam. I laid the third row as well as the rest of the blocks using special adhesive foam. This isn't regular mounting foam, it's a special type with a specific composition. Using it makes the masonry about 20,000 more expensive as of today, but it saves a huge amount of time and effort. Plus, the masonry actually turns out to be warmer, which was confirmed by a future inspection of the house with a thermal imager. Laying with foam was a real pleasure, especially when the masonry gets higher and crawling around with a bucket of adhesive over your head becomes extremely inconvenient. I reinforced the windowsill areas like the first row, but placed rebar only with a half-meter extension past the future opening's edges, not around the full perimeter. When laying blocks from the ground became hard, I built scaffolding from aerated concrete pallets and formwork panels which let me finish the first floor. I bought ready-made reinforced aerated concrete lintels for a few window openings and ordered them from the factory with the aerated blocks. 2 people can easily install these lintels by hand. For the door opening, I didn't use a lintel at all. I just made a temporary support out of a board and glued 2 blocks together with foam. I glued U-blocks with an interior cutout onto a support above the panoramic window. For the 2 windows on the entrance door side, I didn't have any lintels, so on this side I also decided to pour everything into U-blocks from corner to corner. Lacking experience, I overcomplicated things. I should have built a continuous reinforced concrete belt in U-blocks around the walls instead of buying ready-made lintels. It wouldn't have cost much more, but it would have been much more reliable, and it would have prevented a couple of cracks that appeared later. I tied a frame out of 5 12mm rebar rods and lifted it up. I borrowed a concrete mixer from a friend and used it to pour the reinforced concrete lintel. The walls for the house cost me $214,000. At this stage I started running out of money, and as always at the worst time my trailer was robbed too. They stole a lot of tools, 2 sets of car wheels, and I had to leave the first floor walls without a roof for the winter. To protect the aerated concrete block walls during winter, I covered exposed masonry edges with plastic sheeting and sealed the windowsills. Inside I secured plastic sheeting around the perimeter, overlapping onto the walls to keep water on the slab from soaking the first row of blocks. I taped the sheets together after bringing them up the wall slightly. This way, the walls survived the winter without issues. Over the winter, I managed to earn some money, and closer to spring, I bought the floor beams. Since the house is about 7.5 by 8 meters with an open floor plan, the standard 6-meter lumber didn't work for me. So I decided to order laminated veneer lumber beams cut to the length I needed. This pleasure cost me 77,000. Laminated veneer lumber beams are, roughly speaking, large section plywood. I ended up with 11 beams, each 7.2 meters long and with a cross-section of 240 by 90 millimeters. I made the seating areas out of aerated concrete blocks, laid down waterproofing pads, and placed the floor beams in their positions. Despite its large cross-section, the laminated veneer lumber beam is relatively light because it's dry. Overall, it was possible to handle it alone up there. A ladder was needed to continue the work. Basically, I made it from what I had on hand. I built a temporary ladder out of 250 by 150 boards, marked everything with a square at 45 degrees cut, 30 by 40 blocks for the step supports, and secured everything firmly with nails. And the old floorboard made excellent steps. Now it became convenient to climb up to the future attic and lift materials up there. But before that, I had to do a little more work on the ceiling. The individual beams needed to be assembled into a single structure, and for that the beams had to be connected to each other with crossbars. I cut the required size of the crossbar from a 50 by 150 board and drove huge nails through the beams, connecting them with the crossbar. I installed the crossbars every 1 meter 20 centimeters in a staggered pattern across the entire area. Later on, experience showed that twice as many crossbars were actually needed. I used the same pallets from the gas blocks and panels from the foundation formwork to temporarily build flooring around the top wall perimeter for easier movement. Later I realized I did double the work since I had to take everything apart and redo it with proper flooring from good boards. It would have been better to do it right the first time. The walls were ready to be raised higher, so I laid 2 more rows of gas blocks to get a more acceptable ceiling height in the attic. I tried a homemade tool for laying blocks that I saw on YouTube. It looks interesting, but personally I found it useless. After a few rows, you get used to laying blocks and work at the same speed and accuracy with just a trowel. Same as with that tool, so I gave up and moved on. Everything stayed the same. The next row was supposed to be a full-fledged reinforced belt. For some reason, I decided to save money on U-blocks, which was a mistake, and I used 100 mm thick blocks to lay out one of the walls around the perimeter for pouring the reinforced belt. It would have been much more convenient to work with U-blocks, and the joint would have been warmer. If the wall had been 400 mm thick, I could have put foam insulation between the block and the concrete again. But with the wall being 300 mm thick, there was no space for it. Otherwise, the protective concrete layer would be insufficient and the reinforced concrete wouldn't function properly. I thought I could live with what I did, but if I did it again, I'd use U-blocks for everything. I made a reinforcement frame from 4 12 mm rebar rods around all the walls. I cut M16 studs to place them on the sides of the house, where the roof will later be attached to the walls. I placed the reinforcement frame on pieces of insulation to create a protective layer, which ended up being about 30 mm thick. I built the formwork out of boards, and that created the space for pouring the concrete. To avoid ordering a concrete mixer for only 1 cubic meter, I combined pouring the reinforced belt and the future insulated blind area around the house using an angle grinder to cut 3 mm wire welded mesh. The second time I used 4 mm thickness. I laid the mesh around the perimeter and made the formwork another 10 cm from the edge of the insulation. On the outside I set up a 150 mm board level with the ground. Inside, along the house walls, I attached a small bar 2 cm higher to create a slope for water drainage. This way, it will be easier to smooth the concrete and let the bar stay there forever. It will be covered. Finishing the plinth, and if it rots, it won't happen anytime soon. In the future, for similar work, I also tried screwing on a metal plaster corner as a guide. It works even better with it. I built a spot with boards, blocks, and plastic film for the 4 cubic meters of concrete to be dumped. We carried the concrete to the ring beam with buckets and used both buckets and a wheelbarrow for the blind area. For the next few days, I came to the construction site to water the concrete, and sometimes the rain did the job for me. Ideally, to prevent the blind area from cracking, I should have put inserts at least in the corners to create an expansion joint. I didn't do that, and after some time, a crack appeared in one of the corners. Overall, I would have handled the concrete differently, and if I were to do it again, I would try to pour everything at once using a concrete pump. Since later on, in the future, I still had to pour the terrace and the porch, but at that moment, I wanted to start working on the roof as soon as possible, and for that, the first thing I needed to do was make the mauerlat. It's a transitional element that connects the roof to the walls. I made the mauerlat from two 150 by 50 boards and treated them with fire retardant. I also laid waterproofing strips along both sides of the reinforced belt. On top of the waterproofing, I rolled out a jute sealant to prevent any gaps. To secure the boards onto the studs, I needed to make holes. Figuring out the layout took some thinking. I tried several options. I aligned the board holes with the waterproofing using a template, but there was still a large margin of error. I tried pressing the board against the studs and hitting it with a mallet, then making holes where the marks appeared on the board. This method works, but I still had to adjust the holes afterward. The 100% reliable way is to measure directly on the board using a square to mark where the stud is. I nailed the boards together with 90mm nails and used washers when tightening the nuts on the stud. The reinforced belt cost 23,000 rubles and the blind area cost 33,000. The mauerlat turned out to be quite inexpensive. I included it in the total lumber for the entire future roof. Next, I laid more rows of aerated concrete blocks. I cut off the excess at the gables with a handsaw. Using a laser level, I marked the bars and stretched a string between them. I used mortar to lay the first block since the reinforced belt was uneven, then continued the next rows with foam as before. I ordered the wall blocks exactly block by block without accounting for the breakage percentage that always needs to be considered during transportation. And I ended up missing just those couple of percent of blocks from the total volume. And the following year brought a lot of surprises with the price of building materials, which doubled in just 1 year. There were also material shortages. While waiting for the blocks, I used the time to pour a column foundation for the future terrace posts. I dug half-meter holes, filled them halfway with crushed stone, and tamped it down. I built a permanent foam board formwork and mixed cement sand mortar in a bucket with a rotary hammer, then poured it over the crushed stone layer. While the concrete was gaining strength, my brother came to help me, and together we started preparing the rafter system for the future roof. To start, we made 3 beams from leftover laminated veneer lumber timber and boards, which the rafters would rest on. There were some mistakes here as well. For the side beams at the bottom near the post, we shouldn't have rested them directly on the floor beam, but instead run a board along the entire length. But as they say, that's what experience in life is for. While we were assembling this whole structure, the concrete had already set, and with the help of anchors, we fixed special adjustment plates on the posts. For the posts, I used 150 by 150 timber. At the bottom, I drilled holes with a spade bit, secured part of the plate just in case through the waterproofing, and then I could put the timber onto the studs. To keep everything in place, I temporarily fixed the timber to the wall plate with boards and set the top timber. Then I started marking out the rafters. We hauled the board up and leaned it against all the purlins. They were positioned so that the board rested on the purlins, on the wall plate, and on the timber at the porch terrace posts. For this purpose, the screw-adjustable supports under the posts worked perfectly. Using a level and a square, I marked where I needed to make the notches so the rafter would fit well and have enough bearing area. I had to do this for 2 rafters. Cut everything out, bring them both back together again, make sure everything fit exactly to size, and then use them as a template for quickly marking the rest of the boards. To make sure the roof surface was even, I placed the boards not by the edge with the notch, but by the top end. That way, any difference in board size wouldn't matter. I cut them partly with a circular saw and finished them off with a handsaw. Once all the boards were ready, they needed fire and bioprotection treatment. It's more for bioprotection than fire, and actually it gets washed off by rain, but from experience I've seen there's a big difference between treated and untreated wood, so I try to treat all the important parts. Some of the boards are red and others aren't because there weren't 2 cans of red in the store, so I had to get the colorless one. It's actually easier to control the application with the red one. I almost forgot another task, making cutouts in the cantilever beams for the overhanging rafters. I fastened the overhanging rafters themselves using plates made from 2 200 boards and 1 150 board so that I could get a nicer edge on the roof later. My brother and I carried the rafter boards up and roughly set them in place. My brother already had to leave, so after that I was working alone again. I temporarily secured the rafters with brackets using 1 screw each so I could set everything accurately and prevent them from being blown away while I was gone. The spacing of the rafters wasn't standard everywhere at 59 cm. 4 spans were 92 cm each to allow for the possibility of installing 4 skylight windows there in the future. While I worked on the boards, the missing aerated concrete blocks arrived, letting me finish the gables. I used foam to lay the blocks as before. Others might prefer a different order. To lay the gables first and then install the rafters, but it wasn't up to me here, so I had to do it as circumstances allowed. The middle beams didn't rest on the blocks, but the ridge beam was long enough to rest on the gables. Cutting the blocks diagonally made me sweat a lot. It turned out to be a tough job. In the end, I found out the problem was a dull handsaw. I went through about 5 of them during the whole construction, and maybe it makes sense to buy an expensive special handsaw for cutting blocks. A regular one gets dull very quickly. Even with D300 blocks, I also made a notch for the cantilever beams in the gables. And I nailed the pre-prepared 150 by 50 boards to every other rafter just to the end. The cantilevered rafters turned out to be heavy and had to stick out noticeably from the edge of the roof, so I called my friends for help. The metal plates I nailed on were really helpful for making the installation easier. Next, I was in for a good arm workout since I had to hammer in many kilograms of nails. For the top of the rafters, I prepared plates and nailed them generously from both sides. I nailed the rafters to the Mauerlat at an angle and to the beam by the porch terrace, and also secured the brackets well with nails. I also had to make a support board for the roof insulation to rest on. I worked hard with the hammer, and the last step of rafter installation was adding the overhang extensions. This is the extension of the rafter board at the terrace and porch, since the 6-meter board wasn't long enough there. The load-bearing part of the rafter system was finished, and I couldn't wait to get the roofing done as soon as possible. First, I started working on the fascia board, and it almost got the better of me. To be continued. It's not in my nature to give up, so thanks to the first aid kit in my car, I treated the hole in my leg and climbed back up the ladder. I got hit on the head with a board again, but nothing could stop me. I nailed it in place. I used some ingenuity so I didn't have to hold the long board up. In some areas, I pre-hammered nails to rest the board, while in others, I used a metal plate as a holder. Having another person on the roof would have helped, but I did my best. The scars on my body still don't remind me of that day, but as they say, those who haven't fallen haven't risen. The outermost rafters were intentionally not placed right up against the gable, but these spots needed to be closed off with a block. I also decided to fill the gaps at the bottom of the support board around the entire perimeter with foam. The next element of the roof is the drip edge, and here there are no small details, especially when it comes to something like a roof. The only thing I managed to cut corners on was that I nailed the drip edge directly to the rafters and didn't make a special support board for it. I joined the strips together by slightly bending the edge of one and inserting them into each other. Practice showed that this is quite viable. I glued butyl rubber tape onto the drip edge strip. And I rolled out a super diffusion membrane across the roof, attaching its edge to the drip edge. Ideally, the membrane sheets should not only be overlapped, but also immediately glued together. I missed this step, but I'll come back to it later. Rolling out the rolls alone isn't much fun either, especially in windy weather, but thanks to the stapler and the counter batten bars, everything worked out. To be able to move safely up the roof, I immediately installed the battens from 100 mm boards. For proper fastening of the metal tile sheets, the first step was 280 mm. I installed the boards 350 mm apart, center to center, so I wouldn't miss anything and could later add the self-tapping screws. Accuracy of battens is crucial with metal tiles, so precise work is essential. The membrane itself is almost like a roof already, and during a heavy downpour, I made sure that it doesn't leak. Only in places where it is punctured by nails, so in an ideal world it would be better to use a special gasket between the membrane and the counter batten. The construction was finally resembling a house, and it was time for the first barbecue. Before laying the metal tiles, there were still a few more steps to take. I covered the 50 mm ventilation gap with mesh so that insects and birds wouldn't get in there. I bent and installed the gutter hooks, then mounted the eaves strip using the same method as the drip edge. I also had to nail extra boards at the bottom of the overhangs to keep the edges of the metal tiles from bending. I couldn't lay the metal roofing by myself, so while I was looking for help, I started working on bringing water into the house, which had only reached the edge of the property before. I also needed to build a septic tank. A mini excavator made these tasks much easier. We dug a trench to the blind area, finished with a shovel, and brought the water pipe into the house. I decided to save money on the septic tank and make it out of 2 intermediate bulk containers. The mini excavator did a good job with the task, despite the quicksand and constantly collapsing walls. But there's a reason they say a miser pays twice. The trick with the intermediate bulk containers didn't work out. I had to rely on the motto, foolhardiness and courage, and somehow find a way out. I ended up buying 3 drainage wells. I used the intermediate bulk containers as the bottom for the first 2. The third well was without a bottom. I built overflow connections between the wells, and to improve the water dispersion into the ground, I added a polyfiltration system after the third well. So I dug a trench, laid a perforated pipe in it, and covered everything with gravel. To prevent it all from freezing and swelling, I lined the entire perimeter with extruded insulation. And additionally, I connected the wells with a small pipe for ventilation. It turned out to be a fully functional system, where everything goes into the first well and the solids settle out. The second well only gets dirty water, and through the third well and polyfiltration, almost clean wastewater is dispersed into the ground. The first and second chambers will sometimes need to be pumped out by a truck, but over the course of a year, I never had to do it. All in all, even with the lost Eurocubes, it cost 45,000 rubles, and now it's time for the roofing. I didn't order the cheapest metal roofing. I chose one with 0.5 mm thick metal, and I ordered it cut to size right away, so there would be as few joints as possible and less need to cut the metal. But there's a downside to this as well. The downside is that you can't unload long 6-meter sheets like this. And during installation, you need at least 4 people to carry the sheets, otherwise the sheets bend, stretch, and then the waves don't line up, leaving ugly gaps. I didn't know this in advance, so one part of the roof turned out ugly, and it wasn't painful to look at the other part anymore. On top of everything else, I had to install the first side in the rain, and that was quite a challenge. It's like stacking blocks here. The most important thing is to align the first sheet properly. Everything else depends on it. You can align it with a string at the ridge or eaves. It's best to align 2 or 3 sheets at once and fasten them together before attaching to the battens. This way you can align the sheets more accurately so that the metal tiles don't shift by the end. We didn't get it right the first time, so we had to redo one slope twice. Otherwise the screws would miss the battens, and you definitely need to screw them in under the wave. Also, the edge of the sheet at the bottom was almost slipping off the roof and the overhang was too big. If you stick with it, you'll accomplish something. For the first time, we finished both slopes in 2 days.
If you did it to the maximum right now over there,
so that you would screw in 20 self-tapping screws at the bottom into every wave, then every other one in a staggered pattern. I miscalculated the width somewhere. It should have been sheet to sheet exactly. We had to cut part of the sheet lengthwise, so we used an angle grinder, even though that's technically not allowed. Just make sure not to cut on the roof or you could burn through the membrane. And the sparks also damaged the polymer coating of the metal tile. I also tried cutting with a circular saw with an aluminum blade that works. You can do it. It's a bit scary, of course, but you can only get hurt if you get hit by high-speed flying fragments, but honestly it cuts really well. Next, I had to attach the end strips and the ridge cap. I first glued a special aero element to the ridge cap so that snow wouldn't blow into the under roof space in winter, but at the same time ventilation would still work. All the materials for the house roof cost 206,000 rubles. At this point I ran out of money again and thought the house would have to endure winter as it was. However, winter wasn't an issue, and when I could, I ordered windows and a door for the house. Due to limited finances, I ordered the windows with almost the cheapest profile and double glazing, but with good hardware, and I could afford lamination on one side. Even in this case, the windows cost 162,000 rubles. When it comes to window installation, no matter how much of a penny pincher you are, the most rational decision is to delegate the work to professionals, and I'll show you clearly why. There's actually nothing complicated about installation. Mounting plates were screwed onto the frame, and guide bars were attached to the openings using a laser level. For easier frame installation, the perimeter of the mounting area was primed and the windows were unpacked. The glazing bead was removed with a chisel, the glass unit set aside, and the frame screwed into the opening with self-tapping screws. The sash was put onto the fixed frame, with the glass unit left inside, and in this state the windows were foamed. The nuance with foaming is that they used special winter foam and preheated it near a gas heater. The foaming itself needs to be done carefully and not all at once, but in parts, otherwise the expanding foam can seriously bend the frame. The seams themselves shouldn't be too thick or too thin. Mine were between 1 and 3 centimeters. After foaming, the second double-glazed unit was inserted, and that's basically it. This isn't Gosudarstveni standard installation, but I'll explain later. The difficult part was, first of all, the fixed window, because it alone weighs 90 kilograms and during installation there's a high chance that something might go wrong. If you break the window, the cost of the glass unit will be higher than the cost of installing all the windows. Also, the large panoramic window is a challenge, but the real fun is next. On the same day they installed the front door. I wanted one similar to a terrace door, but you can't make that kind of door the main entrance to the house, not because someone will break it and rob you, but because it's really annoying. It doesn't close properly, it constantly sags and so on. On the terrace, as I say, it's used only on special occasions and that's still okay. But for the main entrance door, it's better to use either a warm aluminum profile with double glazing or look for a finished wooden one. I fell for a door with a thermal break and later I regretted it 35,000 times for every hard-earned ruble I spent on it. It was installed using mounting plates on the frame with extra ones screwed on. They used 130mm self-tapping screws tightened securely. They secured the frame without the door leaf to the wall to stop the self-tapping screws from turning. They hung the door leaf, adjusted the lock, foamed it, and that's how I became the happy owner of the keys to my house. The only utility still missing in the house was electricity. I submitted an application for connection almost immediately after buying the plot and waited 5 months for it to be fulfilled. I managed to do it under the old law for 550 rubles. Today, 15 kilowatts would have cost me almost 150,000. The house was locked up, allowing electricity to be moved from the utility shed into the house. In this regard, the meter that hangs on the pole helped me out, and at that time it was possible to turn off the electricity using the meter's remote control. So, we ran the wire into the house ourselves. Using a rough diagram I sketched on a piece of paper, I assembled the contents of the electrical panel myself. The case, the main residual current device, the voltage relay, and good circuit breakers from ABB cost 20,000 rubles. There was no main electrical wiring in the house yet, but it was necessary to connect heaters and turn on the gas cannon so that we wouldn't freeze and could continue working inside. Without the gas cannon, the house cooled quickly, so we had to insulate the roof right away. First, I laid boards across the ceiling beams for flooring and temporarily hung a few light bulbs. The improvised floor is done, so I can begin the insulation. First, I fixed the membrane that wasn't glued well by using Delta tape to attach its edge to the support board. This tape is just some kind of magic. It sticks everything to anything and holds it tight. I couldn't use it everywhere because it's very expensive. I glued the dense membranes together with butyl iron tape. Honestly, I didn't really want to start working with the insulation. I didn't have enough money for good basalt wool, so I bought cheaper mineral wool in rolls. It's fairly convenient to work with, but not without protection. Yeah, even with protection, you'll end up itching all over. I wrapped myself up like an astronaut and started placing the wool between the rafters, span by span. Thanks to the rolls, this is done very simply and quickly. If only I could have found rolls of the right length, but they just weren't available at the time. The most important detail is that you need to cut it 12 centimeters wider than the spacing between the rafters. If you cut it shorter, the roll will fall out. If you cut it longer, the roll will sag in the middle and also fall out. If the rafters themselves are crooked, the roll will fall out too. And some of my rafters are like that. They twisted while drying, causing more difficulties. Even more difficulties awaited me when I had to build up the thickness to 200 mm since the first roll was 150 mm. I had to make up the remaining 50 mm with regular cotton wool, and there was no other way to buy it. While the first rolls held on their own, these couldn't stay in place at all without additional fastening. So I screwed in supporting bars, took garden twine and used a furniture stapler to attach the twine in a zigzag pattern between the rafters, creating support for the cotton wool. Before adding the vapor barrier over the mineral wool, I wanted to check if the insulation was correct, so I got a thermal imager. I inspected the entire house frame with the thermal imager, which by that time was already being heated and could retain heat 24/7. I didn't find any critical issues in the gas block masonry. Everything was fine with the windows as well. The main rule is that air and wall surface temperatures shouldn't differ by more than 5 degrees. For the roof insulation, the area around the wall plate needs better sealing and the insulation near the rafters should be spread out more. The exterior inspection showed no major issues. No thawed patches or icicles on the roof clearly show proper insulation. The mineral wool could be covered with a vapor barrier. I bought one that wasn't the cheapest, specifically so it wouldn't tear like some do at the slightest touch. This type of vapor barrier is easy to install alone, as one staple can support the sheet's weight. The main rule is to overlap the sheets during installation. Unlike with a membrane, the overlap should be from top to bottom, not bottom to top, since vapor rises. It's especially important to thoroughly seal all vapor barrier joints and connections. Delta tape is best for this, but I couldn't afford it. I made do with aluminum tape and in some places used butyl rubber tape. It also stuck the vapor barrier to the aerated concrete on the gable very well. I tried using aluminum tape that cost 300 rubles and it all came off after a year, but the tape that cost 1000 rubles didn't come off anywhere after a year. And on what might seem like such a small thing as tape for ceiling joints in panel frame houses, and my roof is basically a frame structure, you absolutely must not try to save money on the tape. That's why, To seal the vapor barrier at the junction with the reinforced belt, I splurged on Delta adhesive, which I used to glue the vapor barrier to the concrete of the reinforced belt. The warm envelope of the house was ready, and the shell, capable of retaining heat, cost about 1,300,000. Next, I faced a very unpleasant surprise in the form of high humidity. When I entered the house, it felt like a sauna. The humidity was intense, with water running down the windows and large puddles on the floor. This occurred because the aerated concrete blocks are highly porous, each holding up to 3 liters of water, and there are over 1,000 blocks. The water evaporates and has nowhere to go because I didn't realize I needed to heat the house with the windows slightly open. To prevent the house from getting musty and developing mold, I decided to speed up the drying process a bit and put a special dehumidifier in the house. It showed that the humidity inside was 90%, while the upper limit of normal humidity is 60%. After a week of running, the dehumidifier lowered the house's humidity to acceptable levels. The blocks dried well, and then I left the windows slightly open when leaving the house. While everything was drying, I decided to bring the window joints almost up to Gosudarstveni standards. For this, I used STISB sealant on all the foam seams around the windows. This is a vapor-proof sealant. From the outside, all the foam seams need to be sealed with STISA sealant, which in turn is vapor permeable. This method is almost as good as installation using special films, but using sealant is much simpler, faster, and cheaper. I decided to insulate the window slopes inside. There's debate about this, but only those who haven't seen a thermal image comparison with and without insulation argue. With insulation, the dew point shifts and our window slope will never get damp. For insulation, I used 20 mm extruded polystyrene. I used a wire brush for better adhesion, then applied adhesive foam to glue the sheets to the slopes. The school of life threw me another interesting case. While I was insulating the window slopes, I found a crack on the inner glass of the double-glazed unit on one window. There are 3 panes of glass because it's a double-chamber unit, and the cracked one is the inner pane, so it couldn't have been hit by anything. Getting installation from the window supplier is beneficial. If there's a minor defect, you can replace the whole double-glazed unit for free under warranty. Even a small crack is visually annoying, and who knows if it won't spread over time. That's why it's better to have the option to replace such a double-glazed unit. I resolved all the necessary issues and then built the partitions using the same principles as the exterior walls. Spring arrived, the apple trees were blooming, the nightingales started singing, and it was the perfect time to start the interior finishing. Another challenge I had to deal with was a hand injury. I injured my ligaments so badly that my hand simply stopped working. It was my right hand. No matter how much I wanted to, I couldn't continue working by myself. Fortunately, on the other hand, I got the financial opportunity to delegate at least part of the work so that the construction wouldn't be put on hold. That's how Rustam and Safar appeared at the construction site. The hard-working guys quickly finished the first floor in no time. They installed soffit boards to allow for later mineral wool floor insulation. I bought gypsum plaster for rough interior finishing. Before plastering, all the walls had to be primed with a deep penetrating primer, and the first step was installing the mesh. Everything was done not according to the proper technique. You're supposed to apply a thin layer of plaster to the wall, then press the mesh into it, and then apply another thin layer of plaster on top. That way the plaster won't fall off or crack. My guys just fixed the mesh with screws and spread plaster over the top. You're not supposed to do it that way, but the guys got lucky, and as the plasterers say, the plaster didn't drum. In other words, nothing was about to fall off. Beacons were set on the mesh layer to the correct level. Plaster was applied between beacons and leveled with a screed. It took the guys only 4 days of work to cover 50 square meters on the first floor. The window and door slopes were covered with drywall with a metal corner and plastered. A wall chaser was used to cut a groove in the plaster where outlets and switches were planned to be installed. Gosudarstveni Standard certified VVG-NG cable with a cross-section of 2.5 mm was laid in the grooves for outlets and 1.5 mm for lighting. There were no junction boxes on the first floor. Wiring was routed in corrugated conduit along the ceiling sheathing to the attic into the future utility room and to the electrical panel with wires connected in boxes beside the panel. The connections were made using sleeves and a press. Places where electrical connections are made are potentially dangerous, so for peace of mind I placed a fire extinguishing ball next to the panel. It's a kind of automatic fire extinguisher that activates on its own without people being present. I also had to run water pipes inside the house since there was a hallway between the bathroom and the kitchen. We made a small groove in the slab and laid cross-linked polyethylene pipes there. To this day, despite all the promises on television where I live, I still don't have the opportunity to connect my house to gas. I lived with a stove in my previous house, thank you, I don't want that anymore, so in the new house, besides electricity, I didn't have any other options. I chose electric underfloor heating as the main source of heating. Its advantages are the price, ease of installation. For me personally, it was a very straightforward device and its operating principles were clear, the ability to automatically maintain the same temperature in the house at all times, and with proper installation the floor is very reliable. There's a reason some manufacturers offer a lifetime warranty on their cables. An important factor was that this type of heating doesn't require boilers, which means you don't need an additional technical room for it either. The cable heating method isn't without its drawbacks, and if I were building again with a bigger budget, I would consider either a hydronic underfloor heating system or look into modern technologies like XL pipe, which is an electric water-based floor heating system without a boiler. For cable heating, the most important thing is to follow the correct installation spacing, keep the proper gaps, and don't place the cable under future furniture. Ensure the temperature sensor is positioned correctly and avoid saving money on thermostats. Doing so will help the cable heating last for many years. A screed with a self-leveling floor compound is poured over the installed underfloor heating cable with a thickness of 12 centimeters. Just a few days later, you can walk on the floor. The plaster has also almost dried and you can start puttying the walls. Meanwhile, porcelain floor tile installation started. I was always afraid of laying tiles, but laying flat tiles on a level floor, especially using a tile leveling system, is as easy as can be. It's not hard work, and by that time my hand had started to recover. I tried laying them myself and it wasn't difficult at all. I tried not to skimp on materials, choosing good plaster, putty, and especially tile adhesive. With good materials, it's much easier, more convenient, and faster to do the work, and the result is much better. I didn't try to save money. The same goes for glue and wallpaper. I bought good washable wallpaper with quality glue. When it comes to doing things neatly and beautifully, that's usually not my strong suit, so I had Kushkodam do the work. He put up the wallpaper in the house at a 9 out of 10 quality. I came back to work at the plumbing stage. Using a special tool, I pressed axial fittings onto the cross-linked polyethylene pipes. This is the most reliable type of plumbing of all, and it's incredibly easy to do even if it's your first time doing it yourself. We mounted a 100-liter water heater on the bathroom wall and installed a water distribution unit below it. I used a manifold with separate pipes to each fixture, but my inexperience led to several mistakes. If I did it again, I'd use a 1-inch manifold and run smaller pipes around the house than the main supply. I installed the wall-hung toilet frame and connected the wall-mounted toilet myself, and everything went smoothly the first time. In the bathroom, since gypsum plaster was used, it had to be covered with waterproofing. I bought a steel bathtub and additionally covered it with automotive soundproofing so it wouldn't make noise throughout the house and the water would cool down more slowly. I installed the bathtub before laying the tiles, as I considered it more practical because then you can do without baseboards and the bathtub itself is mounted more securely. I applied plenty of sealant along the edge and where it meets the wall, which was enough. An important detail is that I glued the bathtub while it was loaded. I entrusted laying the tiles on the walls to Kushkodam, and as practice showed, that was a mistake. It didn't turn out like with wallpaper, but it was somewhat decent. It's disappointing, but I probably would have done worse myself. Finishing the house cost just over $1 million more, split evenly between materials and labor. The only thing my skills were enough for was installing outlets, switches, and thermostats. The electrical work in the house cost 100,000 rubles and grounding became an important detail. I also did it using a new technology, driving special rods into the ground with a hammer drill without the need for digging trenches or welding. What everyone forgets about is ventilation. To bring fresh air into the house, I used wall valves. Thanks to the filter in the opening and the design of the valve, dust doesn't get into the house, the valves don't freeze, there's no condensation in them, and you can hardly hear the street through them. Bringing in fresh air is only half the job. The other half is exhaust ventilation. For this purpose, I assembled something like a receiving hopper from metal profiles, mineral wool, and non-combustible gypsum boards. I placed a fan inside with a stated maximum capacity of 800 cubic meters per hour and several operating modes for adjustment. I ran the air duct from the toilet and bathroom through the empty space between the beams, connected it to the receiving hopper, and routed it outside through an opening in the house's gable. For the kitchen hood, I installed a separate duct fan with remote on-off capability. This way I got a quiet exhaust system. Taking into account the air quality monitor, supply valves, and exhaust fans, the ventilation system cost about 70,000 rubles. I assembled the essential minimum furniture before moving in, and I especially liked the metal wardrobe storage system instead of particle board cabinets. They brought a wonderful kitchen to the house, and so after 3 years of work and a little over 3 million rubles, I moved into my own house, even though it's not fully finished yet. After that, I mostly kept making the house beautiful myself. Living in your own house makes it twice as enjoyable to do this. I look at these shots and can't believe I did it, because at the beginning of the construction it was really scary. I didn't know how to do anything and really didn't know much, but despite my fear, I took on the tasks and saw them through to the end. The house wasn't just liked by my wife and me. A cat moved in on its own who would occasionally come to me empty-handed and delights us with its purring. Animals showed up in the house and the pond. I released hundreds of crucian carps, so now I can fish from my living room. According to popular belief, a man should build a house, plant a tree, and raise a son. The house will soon be finished, and then I'll have 2 out of 3 so I can start thinking about kids, for whom I still have to turn the attic into 2 living rooms. There are separate detailed videos about each room and every element in the house on the channel. If you have questions while watching, I've probably answered them in other videos on the channel. If not, I'll gladly respond in the comments. And be sure to subscribe to the channel so you don't miss future videos. After moving into the house, at least a draft project of my house finally appeared in the form of 20 A3 sheets which contain all the necessary drawings for each stage of the work. If you're interested or want to support the channel's development, check out the pinned comment. Huge thanks to my friends for helping with the construction. I don't know what I would have done without you. Thank you to everyone who contributed to the construction. Without you, many things wouldn't be in the house, and your help sped up the process. I deeply respect you. I didn't do this alone and will never forget it. I wish everyone who, like me, dreamed of having their own home to make your dream come true. Remember, if I could do it, you can too. This YouTube channel exists specifically to help you with that. I really hope I was helpful to you, and see you in the next video.